So let's have a look at our first 5 MCQ of paper 1, right? And the first question is related to simple harmonic motion, where O is going to be our center, right? When the object starts to move, you should understand at A it's going to be at T by 4, at B, at O it's going to be at T by 2, and exactly at here it's going to be 3T by 4, and when it returns to O it's going to be T, right? So you should understand to travel from O to C, it has to take a time less than T by 4. Right, less than T by 4. So we can eliminate the first three answers, and it has to be the answer number 4 and answer number 5, right? So if you understand, if it was, now let's say the distance between O to A is 2D and C is the midpoint of O and A, right? So this has to be D. So if it was traveling with T by 4, this has to be traveling with T by 8 if they were moving with a constant velocity. And you know that in a simple harmonic motion, we won't have constant velocity. Even constant acceleration is not present. The acceleration is going to vary, right? So it cannot be T by 8 also. Your answer is T by 12, right? And if I really give an idea, if I had T by 6 instead of T by 8, again our answer is T by 12. The reason is from O to C, it's going to travel much more quick. Now I said that if it was traveling with constant velocity, the time has to be T by 8, right? So it has to travel with a time less than T by 8. In a time less than T by 8. Because why? In here the acceleration is increasing. And then it starts to gradually decrease, right? And at this maximum position, it's at rest, right? Now from O to C, it's going to travel with increase in acceleration, and then it used to reduce, right? So it has to be T by 6 from C to A, right? So O to C if it is T by 12 and C to A if it is T by 6, addition of T by 6 with T by 12, you're going to get T by 4 anyways, right? So anyways, our answer for the first one is answer number 5. So copper and lead, right? And at a particular given temperature, they have said the reading was 90 centimeter, right? Now they have just given us the expansivity of copper and lead, right? So with temperature at 30 degrees Celsius, the expansivity of copper would be more relative to lead. So if I consider this as the 90 centimeter mark of the lead ruler, at 30 degrees Celsius, the 90 mark would be somewhere along here. So our reading would be a value greater than the previous one. So the only possible answer is answer number 3, right? If I give a detailed expression for this, now consider a ruler. If I obtain a reading, now usually we used to obtain our reading in centimeters, right? Now when it has been expanded, that means when the temperature has risen, it has expanded. So the length between the scales start expanding. So it's something like now you're obtaining a reading from the other scale. So if I was reading about 4 centimeter, the next case it's going to be about 2 inch, right? So the reading would reduce if the temperature is increased. Now it doesn't matter in here because both of them are expanding. So we have to consider the relative expansion, right? Now let's have a look at question number 3. Now we are having a liquid, right? Now this is going to be our common interface. Let me say the density of this liquid is rho W, and the density of this particular liquid is rho L, right? Now when I add a piece of wooden strip of the same density into this used to float, this particular rod, because the densities of both of them are the same, right? So equal to the volume of him, there will be a volume displacement from the YouTube. So if I initially get an expression between rho W and rho L, you should understand atmospheric pressure pi plus 10 times rho Wg. Now I'm not converting these centimeters to meters since this is an MCQ, right? Pi plus, and this height is 8 rho Lg. From this we can get a relationship between rho L and rho W. It is 10 is to 8, right? Now when I add this wooden strip, additionally there would be a height raised. Now the volume of the wooden strip is 1 centimeter squared times 3 centimeter height, 3 centimeter cube. So there has to be equal volume displaced from the U-tube. but the cross-sectional area of the U-tube is 3 centimeters squared. So it has to rise by a height of 1 centimeter, right? So if it is 1 centimeter, the total height of this liquid would be 11 centimeters. And if I again rewrite the expression, pi plus 11 rho wg is equal to pi plus, let's say this height is h dash rho lg. From here again I'm gonna write the same expression, L over h dash is equal to rho L over rho W. From the previous expression, you know that rho L over rho W was supposed to be 10 by 8. So if I substitute 10 by 8, I would get an answer of 8.8 centimeter. Right. Now let's look at question number 4. Now again, this is related to period. That means simple harmonic motions. Right. Now they have said in a particular tube at a certain distance, a particular mass is held. Right. So when I oscillate it along a point, the period was t, it seems. And when I oscillate about the other point, the period was 2t, twice the period, right? So if I name the center of mass, the distance to the center of mass from this point as x, the entire length is L, so this has to be L by x, L minus x. So if I write expression for my period, initial period is t, so t is equal to 2 pi, distance to the center of mass, x over g. And from here if you look at 2t, which is 2 pi square root of L minus x over g, right? So if I divide both these expressions, I would get 2 is equal to L minus x over x. From here we can get a idea about x, which is L by 5. Now this is not the question. They are asking us what's the distance of the center of mass from the center of the tube. So the center is going to be exactly at L by 2 from here. So this is going to be our distance, L by 2 minus x. L by 2 minus L by 5 would be 3L by 10. So that's going to be our answer, right? Now let's have a look at question number 5. Now equal masses are placed on 3 tubes, right? And this is related to Pascal principle, right? And initially the valves are closed, but their cross-sectional areas are different. Now we know that pressure is inversely proportional to the area. Now the force is the same, so we can just write pressure is inversely proportional onto the area. So the pressure executed on here would be greater than at here, and it would be greater than at here. Now when I open a chamber, from high pressure to low pressure liquid starts to flow, right? So the level of this used to reduce and the level of this used to increase. Now they would name it as PQR. Okay, so P would reduce and Q would increase. Now until which point? Until their pressures become the same, right? So if you understand, he used to move a distance downward and this used to move a distance upward such that the total height would be, now if you understand, the pressure here PQ plus 2H rho G is equal to this pressure exactly at this point. Until the pressure gets equal, liquid starts to flow, right? So that answer is only possible in answer number 5.